Hello, my name's Dominic, and among my responsibilities at MGmbH are rear axle development and integration in the vehicle. Here we see the rear differential of the new M3 M4. It's based largely on the one in the F90 M5 and was adapted in the mounting points at the front and the back. A rear differential in M vehicles fulfills two important functions. Firstly, of course, power transmission, and secondly, it can also be locked via the limited slip differential and thus contributes greatly to the vehicle's driving dynamics. The first function, the torque coming from engine and main transmission, is transferred via the cardan shaft here, arrives at the drive pinion here, that's this component, is transferred within the transmission by the drive pinion to the ring gear, and then via the differential output gearing to the left and right wheels. In the G80 M3, two different ratios are used, a 3.15 in the automatic transmission and a 3.46 in the manual. In contrast to its predecessor, we were able to reduce the weight by up to 2.5 kilos through optimization, despite better rigidity and performance capability on the part of the transmission, and further optimize the efficiency through the use of a low-friction oil. Besides power transmission, the second important function of a rear differential in M vehicles is the differential lock. The basic system was taken over from the predecessor and developed further to achieve greater accuracy and precision. On the outside, all that can be seen of the system, which is an electromechanical multiplate limited slip differential, is the electric motor, which, via the adjustment of the ball ramp mechanism inside the differential lock, presses the plates we see here together and thus generates locking torque.
Zusammendrückt und somit ein Sperrmoment erzeugt.
The plates consist of a friction plate and a steel plate. The friction plate here is fitted with woven carbon friction linings. The locking torque generated is infinitely adjustable and defined in the end by a central driving dynamics controller.
Und wird letztlich von einem zentralen Fahrdynamikregler bestimmt.
The locking torque depends on the road conditions and the input from the driver to the vehicle. On the one hand, the locking torque is needed to guarantee good initial acceleration traction, but also sufficient traction when accelerating out of corners, particularly out of tight bends, and on the other hand, to give the vehicle unique agility and dynamics when cornering. That's because the locking torque also allows you to generate a yaw moment in the vehicle, which then supports the cornering motion. The locking torque in the rear differential is set according to road conditions, but also driver input and selected driving mode. In the driving modes DSC, DSC off and MDM, different settings are used which ideally complement the overall vehicle characteristics in the desired operating mode. The unique features of this transmission compared to other axle drives are on the one hand the horizontal division, which is clearly visible, up here the black cast iron housing, at the bottom the sump in cast aluminium, and on the other hand this adapter plate here. To see what that's all about, let's take a look at the vehicle. The first thing that strikes you about the rear differential is the sump with all the cooling fins. Now we can also see the point of the horizontal division. It serves to integrate the largest possible cooling area. That's required for safe and reliable operation on the racetrack, as that's where high power losses in the transmission occur. To ensure an effective cooling of the rear differential and the differential lock in this situation, we need a correspondingly large cooling area. Because, despite the transmission's excellent efficiency, in many areas over 98%, at maximum acceleration at 375 kilowatts, a performance loss of about 7 to 8 kilowatts can occur. That's enough to heat a small house. Another decisive point in the integration of a rear differential besides the cooling is the connection to the vehicle. And this is where the adapter plate I mentioned comes in. The adapter plate has 4 rubber bearings, whereby the outer rubber bearings are connected to the rear subframe. This enables optimal decoupling of the transmission from the rear subframe, which in turn leads to less background noise in the interior. At the same time, we can mount the rear subframe rigidly to the chassis, and this direct chassis connection in turn leads to better driving dynamics characteristics. Personally, my favourite detail in the rear drivetrain is the design of the output shafts. If you look closely, the left output shaft has a slightly larger diameter than the right one. That means that in difficult, wet conditions, we have a much more harmonic acceleration behaviour in conjunction with the differential lock, thereby ensuring optimum traction.
In Verbindung mit der Sperre zusammen.
A small detail with a large impact.